Welcome, everyone. So we're looking at the limit as x approaches 0 from the right of this function 1 plus sine 3x to the power 1 over x. So if you try to approach this limit, you'll see that you'll have, if you substitute 0 into sine 3x, you'll get 0, so you have 1. And then if you try to sub in 0 here or 0 from the right, since you cannot sub in 0, you'll have a very tiny number in the denominator. So 1 over that tiny number will be very large. So we can say that this will go to infinity. So this is an indeterminate power. It's one of the cases of indeterminate power. Now, if you have such problem, then this is how you're going to approach this. So we're going to go ahead and introduce a variable. So let y represent this whole thing right here, this entire given function. So you have 1 plus sine 3x to the power of 1 over x. Now, I'm going to rewrite y in a different way. So remember this from maybe from your previous knowledge, that if you want to rewrite this in a different way, you can write this as e to the ln of y. So we know that's true by laws of logarithm because these can cancel each other, so you just have y. So that's the purpose of doing this. We're going to apply natural log on both sides, and we're also going to exponentiate at the end so that we can go back to the initial problem. So if you now apply, so hold on to this dot, and now let's go ahead and take natural log on both sides. So you'll have ln of y is equal to ln of 1 plus sine of 3x to the power 1 over x. Now, by laws of logarithms, I can bring down the power. This gives me 1 over x. So we're just working with this piece right here. So I'm going to take the limit of that. And then once I get an answer, I'm going to exponentiate. So hold on to that thought again. So let's go ahead and rewrite this. So this can also be rewritten as ln of 1 plus sine of 3x over x. So now that's where I'm going to sub into my limit. So we're taking the limit of this function, which we're calling it y. So we're really taking the limit as x approaches 0 from the right of y. Well, what is y? Well, y, when you take the natural log, it looks like this. So I'm going to replace it with that. So we're really taking the limit as x approaches 0 from the right of ln of y. And ln of y is represented by that simplified version. So this is the limit as x approaches 0 from the right of ln of 1 plus sine of 3x over x. Now let's see what happens as you take the limit. So if I take the limit now, I'm going to get, substitute 0 here. You'll have sine of 0, that's 0. 1 plus 0, that's 1. ln of 1 is 0. Over, on the denominator, we get 0. So this is an indeterminate form. So because it's in this particular indeterminate form, now we can apply L'Hopital's rule. So we make an indication that we're using L'Hopital's rule like this. And the L'Hopital's rule tells us that if you're taking a limit of a function, you differentiate the top and you differentiate the bottom. If you have either 0 over 0 or infinity over infinity. So I'm going to take the derivative of ln of 1 plus sine of 3x. And then on the denominator, I'm going to take the derivative of x. So that's L'Hopital's rule. Now let's see what we get here. So if we do that, we have the limit as x approaches 0 from the right. The derivative of ln of 1 plus sine 3x, that's 1 over 1 plus sine 3x times the derivative of the inside. So that would be derivative of 1, that's 0. Derivative of sine 3x, that's cosine 3x times 3. So I'm just going to put it in the front. All over the derivative of x, that's 1. And now just rewriting this before taking the limit, we have the limit as x approaches 0 from the right of 3 cosine 3x all over 1 plus sine of 3x. And now we can take the limit. So we do direct substitution, plug in 0 here, plug in 0 here. You'll have 3 on the numerator because cosine of 0 is 1 and sine of 0 is 0. So you'll have 1 on the denominator. So this limit is 3. Now remember, this is not the final answer because we are looking for the limit of y. And all we did was we took the limit of ln of y. So to undo that, we're going to have to exponentiate that. So that's why I needed to write that beginning of the problem so that you know what we're going with this. So I got the answer for y. And since we know that y is written as e to the ln of y, and now if you take the limit as x approaches 0 from the right of y, you're really taking the limit as x approaches 0 from the right of e to the ln of y. And you can also write this this way. This is e to the power of limit as x approaches 0 from the right of ln of y, because it's a continuous function. And what we have figured out is this piece right here. That limit is right here. It's 3. So that's where I'm going to substitute. So I have my final answer as e to the power of 3. So that is our final answer to this problem.